Hello, students. Let me start with a question. Have you ever climbed a flight of stairs or gone up a hill and felt completely exhausted at the top? That tiredness you feel? It's because your body is doing work against gravity. Yes, gravity, the invisible force that always pulls objects downward, plays a major role in the work energy story of physics. Whether you lift a bag, climb stairs, or ride an elevator, gravity is involved. And whenever an object moves vertically, either up or down, the force of gravity does work. Let's explore exactly how and how much. Let's derive the formula for the work done by gravity. Suppose we lift a body of mass m vertically through a height h. The force of gravity acting on the object is F equals m into g, where m is the mass in kilograms and g is the acceleration due to gravity, approximately 9.8 meters per second squared. Now the displacement is in the vertical direction, and its magnitude is S equals h, where h is the height moved. So, work done W equals force into displacement. Substitute the values. W equals m into g into h. This is our key equation for gravitational work. Here, W is work in joules, m is mass in kilograms, g is gravitational acceleration in meters per second squared, h is height in meters. Now let's understand how direction of motion affects the sign of the work. When an object moves downward, like a book falling off a shelf, the displacement is in the same direction as gravity. In this case, the work done by gravity is positive, so we use W equals m into g into h. But when an object is lifted upward, like a boy carrying a school bag up the stairs, then displacement is opposite to the direction of gravity. So gravity opposes the motion. In this case, the work done by gravity is negative, and we write W equals minus m into g into h. That's right, gravity resists upward motion, and that's why you feel tired lifting things. Here's a cool insight. It doesn't matter how the body moves vertically, whether you walk up the stairs, slide down a ramp, or ride a lift. The vertical height h is what determines the work done by gravity. This means even if the actual path is longer, as long as the vertical displacement is the same, the work done by gravity is still W equals m into g into h. So the path doesn't matter, only the change in vertical height does. This explains why elevators and escalators are designed to reduce human effort, but the gravitational work done remains the same. Let's solve an example. Suppose a student lifts a bag of mass 10 kilograms to a height of 5 meters. How much work is done by the force of gravity? Let's apply the formula. W equals m into g into h. Substitute values. W equals 10 into 9.8 into 5, which gives us W equals 490 joules. So, gravity does 490 joules of negative work, because the motion is upward. If the same bag was falling downward instead, gravity would do positive 490 joules of work. Also remember, 1 joule equals 10 raised to the power 7 ergs, if you're working in CGS units. Let's quickly summarize what we've learned. The work done by gravity depends on mass, gravitational pull, and height moved. Formula: W equals m into g into h. If motion is downward, work done by gravity is positive. If motion is upward, work done by gravity is negative. Whether the motion is on a slope, lift, or staircase, only the vertical height matters, not the path. So the next time you lift something up, remember, you're doing work against gravity, and when something falls, it's gravity doing work on it. I hope this helps you understand why climbing tires you out, and how even a falling apple is a perfect example of work done by the force of gravity. See you in the next concept, where we'll explore power, the rate at which work is done. Until then, stay curious and keep applying physics to everything around you.